Hello, internet.
And if you haven't hit
Well,
record,
I
actually,
see a massive
no.
countdown.
Oh, yeah, okay. Hello, internet now. I think they're still counting down earlier.
uh-oh,
Oh dear, we
did
lost
we
him.
lose? Uh-oh, oh, he's coming back. And there we go. Hey, can you hear us?
Yeah.
Cool.
Sorry about that. It made me refresh. So,
Ah, okay. And it looks like we're live on YouTube. Hooray! Hello, YouTube.
Hello from the dungeon, as
Hello,
apparently my
YouTube.
background looks like.
It's like 90 degrees in Massachusetts, and I have like no air conditioning, so
Oh, that's brutal.
the internet can watch beads of sweat form on my bridge, and I'm just like wipe it and try to look cool, you know.
Okay. Any questions before we get started?
nope.
K-Ball, you're starting to really pixel out.
That tends to happen to some people. Jared specifically for me when when we start recording. But
Yeah.
I think the audio will be okay. And you're recording
Okay.
locally. If
I'm
you haven't started
recording
that
locally
recording,
twice, in fact.
Cool.
Once on my H4 that I could not get to connect, and once on my laptop just in case.
nice. Okay, and then I'm gonna play the intro song, and then I'll kind of do introductions, and we'll kick off from in there. All right.
Oh, so Nick, actually super
Yeah,
quick, I'm
sure.
really interested in like hearing a little bit of David's backstory and like the origin story for the project, like how it got started, what was like the inspiration behind it. And from my understanding, like it uses like a spec that's like really old for state machines, and so I'd
Yeah.
love to kind of like get into that as well, maybe for the first segment.
Yeah, I think that's great. I kind of had on the sheet to like talk about state machines in general, and I think that's just a perfect place to start, and
Segue
maybe
into that.
starting with David's background and getting into that. So yeah,
Yeah,
it's perfect.
because David, all I know about you is you worked in Microsoft, and you didn't really hit my radar until this project, so I'm curious to learn about
Okay.
what else you've been up to.
Sure.
Not that that's a bad thing, obviously.
No, it's all good.
My radar is not a bar.
All right. Any other questions, or I'll go ahead and hit the intro. Cool. Let me take that live, and there. Hello, Internet. Welcome to JS Party. I'm your host this week, Nick Nisi. Ahoy, hoy. And I am joined by two wonderful co-panelists. K-Ball. What's up, K-Ball?
Oh, good to be back. Hello, everyone.
Welcome. We're happy to have you back. And I'm also joined by Amel. Amel, how's it going?
Hello, hello. I'm having a fangirl moment, so I'll have to restrain myself today.
Absolutely. I think we all are. It's a very exciting podcast today. Today we are talking to David Khourshid. David, how's it going?
Going good. How are you all doing?
Fantastic. And we are talking about you and your fantastic project, XState. And so why don't we kick off learning a little bit more about you? Tell us what's up.
Sure. So, you might have noticed my screen name, David K. Piano. The piano is not my last name, as you probably surmised. I went to college for piano and then discovered that doing web development actually pays a lot more than playing piano. So I sort of switched fields, went into that. And I started at a startup, as a junior developer. And it was like this startup where there were just all of these crazy workflows and multi-part forms, and like one of those things where like you would click a checkbox and then a certain field would show unless this other checkbox was clicked, then you have to do this and you might go to a different step, etc. And that was just really confusing to me as a junior developer. So I'm like, there's got to be a better pattern for doing all this. So I was doing some research, and I actually just stumbled upon state machines. So it's nothing that I learned at university like a lot of other, developers might have learned. It's just like, wow, this is a nice visual language, and I'm a visual learner. And as a musician, like that's important too, because you have sheet music, which is a visual way of representing like what you're supposed to play. And so I was like, hey, I really dig this visual language. Let's dig more into it and actually find out why it's not more popular today. And so fast forward a few years, I decided to just put all of my learnings into what at the time was a toy project. I actually called it Estado, like the Spanish word for state, but I eventually changed that name. Yeah.
That's awesome.
And so that toy project had all of 7 GitHub stars for many years until I actually decided to give a conference talk about it. And yeah, so it became XState, and here we are. I have a lot of really good contributors working on it, and I'm just really excited like where it's gotten to right now, and where it's going to be in the future.
Before we dive into XState, I'm curious to hear more about piano. Do you still play a lot? I know multiple developers who development is like their equivalent of serving tables, right? It's how they pay their way for their either professional music or professional theater or whatever it is career. So are you still going strong on the piano?
Yeah, I am. In fact, my piano's right here. Actually, I mean, the piano's actually over there, but I have a Lego piano right there.
They look very tiny.
Yeah.
Tiny piano.
Yeah, it is playable actually. But yeah, from time to time I still perform, just at small like concerts, things like that. So yeah, try to keep it up.
That's very cool. And is there any kind of correlation between instruments like that and state machines? Now that you've really dug into those?
I would say the only correlation is the fact that like what I talked about, sheet music, a visual representation of like you have notes and bar lines and like just a really limited set of notation for expressing a huge variety of music, like centuries worth of music. And I'm like, okay, is there any sort of visual, whatever it's called, visual formalism that exists for application logic in the same way? And so I think that's the connection. Like just state machines and state charts can really describe not everything, but almost everything.
Yeah.
Okay, so I'm like really digging this analogy, and I don't consider myself like a state machine nerd because like I'm very familiar with people who really love nerding out about state machines, and a lot of my state machine nerd friends who happen to also write JavaScript for a living love XState, and I'll share some interesting backstories later. But this kind of analogy of like the state machine needing a visual representation and how it's similar to sheet music. And if you really think about an orchestra, I mean, it is this giant kind of state machine between multiple musicians that need to coordinate events and activities in a synchronized fashion, for a set duration of time. And so, I mean, it really is a very interesting analogy. And I think like your background and your story is just like one small example of like why diversity in tech is super important, not just age and race and ableism, but like literally like what did you do before this job? You know what I mean? Like that unique perspective that you bring, it's just, it shows in the way you approach problem solving. And so, we're really lucky to have you. And yeah, glad you picked this profession to help pay your bills because, yeah.
Thank you. Yeah.
So before we dig too far in, maybe let's take a step back and define what a state machine is.
So state machine, it's one of those things that sounds really, really complicated. And it's like, I need to go get a CS degree or something in order to really understand it. But as scary as it sounds, it's actually pretty simple. A state machine is like, you could describe something, like even a human, let's use me as an example, as being in one of a finite number of states. And I can't be in more than one of these finite states at a time. And so an example of a finite state would be sleeping. or awake. I'm either sleeping or awake. I can't be both sleeping and awake. Otherwise, I have to go see a doctor and deal with that whole thing. Don't want to do that. So I could only be in one of those states. And I could also transition between sleeping and awake. So if my alarm goes off, hopefully I go from the sleeping to the awake state. And so what finite states really are behaviors. And by behaviors, I mean how you or how some entity reacts to events. So I'm going to react differently to events when I'm sleeping versus when I'm awake. And so finite state machines are just a collection of those behaviors or finite states and events that come in. So a more practical example, I mean, this is JS Party after all. So like, let's talk promises and fetching data. Like you're either loading data or the data loaded or there's an error, but you're not going to have more than one of those happen at the same time. You can't get both error and success, or you can't get both loading and error. And the problem today is that there's lots of applications where they do that. Like I'm sure you've run into an application where it's like, this loading spinner, I know my internet's fast, but this loading spinner has been going on for like 2 minutes now. I'm pretty sure there's an error, but it's just not going to tell me. It's going to show the loading spinner indefinitely. So problems like that are solved by state machines where that's impossible. You can't be both in an error state and a loading state. You have to be in one of those.
Wait a second, David. Are you not familiar with a tiny little project called GraphQL? So I feel like GraphQL is like broken all the rules there. I mean, you can get your success response, you can get partial response, and you get a list of your errors. And of course, like zero respect for HTTP codes, and everything is a post, and like what the F, So like. I mean, I love GraphQL, but like, some things about the spec are really bothersome to my heart.
I think GraphQL is highlighting David's point, right? So
yeah.
The web in general, like anything on the web, people will say like, hey, can this happen? Hey, it's the web. Anything could happen. You could ask for things in order. They could come back out of order, all these other things. And what the state machine lets you do is like collapse that infinity down to a few manageable states you can think about.
Right. Some determinism, right?
Mm-hmm.
You want determinism. Yeah. So then
you use
like,
that word finite, and is that just synonymous with state machine? Like if you're talking about a state machine, is it always a finite state machine? And does the word finite mean there's a finite number of states, or there's a finite number of states I can be in at once?
So finite is basically how you organize all of the possible, states that your application can be in. And so it's more of a communication mechanism than reality, because obviously in this world, like, there's infinite number of, different states that things can be in. But like finite is just for, grouping. So for example, sleeping versus awake, like my body is still the same number of cells. It's just that some are sleep. I don't know how. I didn't take anatomy, so like however the body works. But yeah, it's just that we discretely define sleeping and awake as two separate states. And so again, it's a communication mechanism, and it's a necessary one too, because we as developers want to talk about what can happen in certain states instead of like, oh, just check this Boolean flag, and if this is false and that's true, and this and this are false, then do this. Like that's really confusing. And so yeah, it's a social construct, sort of.
I think we do have to be careful too, right? So sleeping and awake is a really convenient pair to talk about.
Yeah.
Some sort of way to capture the state of mind, which is I fell asleep on the couch, but now my 8-year-old has jumped on top of me. I'm definitely not all the way awake, but I don't think sleep
Right.
captures that either.
Right. So, and I mean, we're going really forward here, but that's where you get into state charts, where now you have all of these little states, like this half sleep, half awake state, where you're definitely not sleeping, you're definitely not fully awake, but you're like in between there. But you could say that's a subset of being awake, or maybe a subset of being asleep, however you want to categorize that. And state charts help you organize that.
I like that. So I haven't dealt that much with kind of layered state machines in that way. So how do you think about that when you have these sort of substates that are going on? Is it kind of similar to, you might think of a class hierarchy or something, where you inherit things from the above state, but you can override things? Or how else would you address that?
It's not so much inheriting, it's more just grouping similar behaviors together And yeah, just the way it works is by event propagation too. So basically, when you have a state and that state has nested states, those nested states take priority. So if an event happens, those smaller child states are going to respond to it first. And if it doesn't handle it, it goes to the parents, etc. But all state charts can be made into state machines. It's just that when you convert a state chart to a state machine, you get what's called state explosion because you get all of these unorganized states. And so, honestly, I think this is sort of meta, but that's one of the biggest reasons for the learning curve behind XState is that there's so much to learn with state charts. But I want to emphasize that state charts are just an organization mechanism. It's one of those things where you don't have to learn it all before you start using it. Just know that there are tools there that help you, better organize your states. And all of this is a lot better than, of course, organizing like a ton of Boolean variables.
So if I was to play that back to you, the state machine is essentially the flattened version. It doesn't have all the context of how these states relate to each other, except in the rules that are written out. And so it can be potentially hard to understand that higher level structure, whereas the state chart is kind of a grouped set of state machine pieces so that you can see that bigger picture a little bit more. Oh, these are really substates of this, and this is how they relate to each other and what priority. Is that a fair assessment?
Yeah,
Cool.
Exactly. I mean, imagine making like a web page where you have no nesting of elements. That would be your state machine. So state charts are sort of the revolutionary thing that says, hey, you could nest elements however you'd like.
Yeah, so I mean, it's a really great summary and analogy, David. Great summary, K-Ball. Great analogy, David. So points for both of you. So for me, like, I think this concept of like encapsulated states is, maybe something that isn't explicitly said here. Like, having kind of that encapsulation where nested states are not necessarily triggerable by higher level kind of state machines, right? So you have to get to this path and take this left and take this right in order to trigger this nested state. Like, that's kind of cool. But I think for me, it kind of like, it still goes back to that like age old question of like local state versus global application state, and like when to encapsulate what, right? Like if you have a calendar icon and not icon, a calendar widget, and a user's picking their dates, and that maybe that's part of a form, and let's say you want to have some form state. What are you persisting? What are you saving? What's application state if the user wants to rehydrate? After a refresh, like where are you bringing them back, right? Like, and I think for me, that's something that XState doesn't have a strong opinion on, right? Like, it's kind of like you design it how you want to, but however, like I do think like there are still some principles around encapsulation when something can be shared by other things and when it should trickle down, and also like the directional management of state events, like that's still a little bit fuzzy, I think, for most folks, including me. I always have to think about it. It's never like it's not always like an automatic thing for me where I know how this is supposed to flow, and it's okay to also refactor and you get it wrong,
And so that's where we get into the actor model. So that's sort of like the second half of XState, which again, people think it's a big learning curve, but it's actually a lot simpler, than you might think. So with the actor model, instead of having just this one giant state chart, like just sort of determining, or even like ad hoc machines, like just figuring out like the logic for different components, you have this actor model where you have individual actors where you could think of them like class instances or just like things that you could send messages to. And the behavior of each actor is guided by a state machine. So an actor can send a message to another actor. So for example, you could consider like if you're listening for mouse move events on a DOM element, that's an actor. And so when you're setting up add event listener and checking for those mouse moves, you would send those events probably to something else. And so that would be another actor. And so that actor might be in charge of like coordinating all this movements, like, if it's a drag drop actor or something like that. And so that's another conceptual shift, at least in front end development, is thinking of everything in your app as like just little entities talking to each other. And it's also something that's very different than, for example, Redux, where Redux, it's like, okay, everything is in this one global store. And if you don't have, things that fit in this global store, good luck. Find somewhere else to put them. They can't live in Redux. And so XState takes a different approach, and it's like, it doesn't matter whether it's local or global. You could set up that actor hierarchy however you want and access it wherever you want. And yeah.
Sounds to me a lot like the type of encapsulation we're used to thinking about in terms of data for component level data. But in this case, yeah, it's not just data, but it's this whole state machine of like, what are the potential states? Can you compile that set of actors up into like, is this once again sort of syntactic sugar to help us think about this? Could you compile that up into a single global state machine if you wanted to? And if so, are there any sorts of interesting like analyses or invariant checkings we can do on that?
That's such a great question.
Yeah, so as far as like compiling like a bunch of actors into a single state machine, I would say not really. It's sort of like asking like, can we compile all 4 of us into a single mega human? Doesn't really work that way. But as far as state machines itself, that could compile down to just like normal code. You don't need to use the library. And in fact, I wrote an article, you don't need a library for state machines. But actors sort of work the same way too. It's just this contract between objects where you could just talk to different objects.
So what constitutes an actor? And also, by the way, does this mean, Cable, that like 9 women can't make a baby in a month? Because that just like ruins my plans.
I have heard that, yes. No, I guess where I was trying to get to is like, conceptually, where are the lines of a state machine? And because one of the real benefits of state machines is that they're like extremely analyzable, right? You can put something in state, you can reproduce that state exactly, you understand what's going to happen here. And when we talk about breaking apart into actors, I think that there is in and of itself kind of a useful abstraction there, right? The actor model for thinking about things is quite useful. Message passing is a nice way to delineate things. And within each actor, you have that property of there's a nice analyzable state machine. But it does make me wonder, right, if we put in the restriction of only actors can send messages to actors. So we're keeping everything is within our sort of model of XState state machines and XState. So this is all hypothetical in my head. You have a much more concrete model. At that point, every message is potentially the result of an action or of a state transition or something along those lines. So conceptually, these state machines are part of a larger. If we say only actors can send messages to actors, all actors are themselves state machines, then we should be able to do some amount of combination of actors and say, okay, even though it's a useful organizing technique to have these be isolated, we can model them as one larger thing so that we can run global checks and say, are there loops that we might get into or other situations where this is not a valid state machine?
All right, I understand you now. So yeah, this is more along the lines of orchestration. So with orchestration, you have like this hierarchy of actors where, again, this is not global state like Redux, but you have like a global orchestrating actor, and then you have maybe child actors that were spawned by it, and those child actors could also spawn child actors, and all of these actors could be talking to each other, but you are ideally organizing your app in a way that you have a central orchestrator, just like an orchestra conductor, that is receiving messages and maybe delegating to other actors, okay, you do this and you do that, sort of like working at a company where it's not coworkers telling each other what to do, at least hopefully. It's more like the manager is understanding what needs to be done, is getting changes as they happen and other signals, and then is telling their employees like, okay, you do this, you do that. So doing it that way, you could think of like just this massive network of actors as just like you have a central orchestration unit, and events come in from the other actors. So you don't need to worry about like, okay, well, how do we like combine those actors together? Just know that there's a potential number of events that are going to come from somewhere. And so with that, you could fully test the system, or you could fully test your orchestration and ensure that, hey, if this event comes in, this is going to happen. If this other event comes in, then this behavior might change, and then this might happen. Yeah, so abstracting it that way, it actually makes it a lot easier to test. And that's sort of one of the central ideas behind model-based testing, it's called, where you're not even thinking about like, oh man, I have to mock this, I have to make sure that this is integrated with that. It's more like, okay, everything is just events. So you receive those events, and you receive like just a whole bunch of combinations of events, and you ensure that the state resulting from those events is as expected according to your model. Yeah.
Let's break there.
Yeah. So I'm still a little fuzzy on like what constitutes an actor, and just also I think kind of the responsibility of orchestrators versus whatever. So I think maybe if we could dig into that a little bit more, I think,
Sure,
and
sure.
Flesh out just kind of the moving pieces of XState, that would be great. And then we can maybe get
Yeah.
into like tooling and all of that other fun jazz.
Yeah.
Okay.
Story time, maybe third segment. But anyways,
Sure.
here I am. I'm being bossy. Nick, tell me to shut up.
No, it's
That's
great.
all good. We sort of jumped like way straight into actors, and I'm like, wow, this is advanced stuff, but that's okay.
Yeah. I think it's.
Sorry, that's probably my bad.
No, it's all good.
I get
Really
excited
interesting
about
questions.
stuff. So I just
Gosh,
dive into it.
K-Ball. Restrain yourself, okay?
No,
We're
that's
not
good. Yeah.
all at your level, Kevin. K-Ball.
Does anyone need a break?
Good. I need air conditioning. That's about it.
Can't help you there, unfortunately. Okay. Amel, do you want to lead us into the next section? then?
Yeah, sure.
All right.
All right. Ready? Uno, dos, esteto. So, yeah, I definitely just said uno, dos, esteto. That happened because, XState was originally, it's formerly known as esteto. That's
Not to derail, but I would love to know why you didn't stick with that.
Yeah, exactly. Who made
don't
you
know.
change it, darn it?
Okay,
You know?
there was Redux, MobX, like there's the whole X thing was going on. So I'm like, okay, I have to find something with X, and XState was available, so I took it. And then I backpedaled and like added meaning to the X, like it means like a transition, like a crossing of some sort. So I'm like, I have no idea what they mean in Redux and MobX, but at least I came up
They
with
mean
some sort of
nothing.
meaning. Yeah,
They mean nothing. Yeah.
it's
And
just cool. It's a
They're
cool
just
sweater.
they're remixes. They're remixes and available domain names. You know what I'm
Yep.
saying?
Yeah.
And GitHub names. But anyways, so back to question time. Back to the interview. So we talked a little bit about orchestration and actors. We kind of did a little bit of a deep dive. So I'm just gonna ask you to just like take a few steps back because I'm a little lost. So can we talk a little bit about like what actually constitutes an actor? What is an orchestrator? And really like what are the general moving pieces for production level XState state
Sure.
machine,
Yeah, so actor, think about ourselves really. I'm an actor, not like an actor, but like I'm an entity, and I'm just calling us an actor. Nick's an actor, K-Ball's an actor, Amal, you're an actor. So
I'm
what
an
we're
actor.
doing, actor. So
I'm actually a diva, thank you very much. But
all right,
sure.
well, subset of actor.
Yeah, specialized
But-
subclass of actor.
Thank
yeah,
thank you, gentlemen, thank you.
So with actors, what we're doing right now is we're talking to each other. We're sending each other messages. And so that's like one of the primary functions of an actor. The way that actors communicate is by sending messages. And so actors can send messages. Actors can receive
Listen.
messages, of course.
Could they choose what they want to listen to? Is it
They can, yeah, and so that's an actor's behavior. So I have a behavior, and that behavior can change depending on the message that I get. Like if someone offends me on Twitter, then my behavior might be a little bit different. So it depends on the messages you receive. And also, actors have their own local private state. So with this whole analogy, I have thoughts in my head right now. You're all thinking something. I don't know what those thoughts are. I can't read your mind. So how do I get that information out of you? Well, I ask you, just like you're asking me questions right now. We're sending a message and we're hopefully anticipating a message back. Otherwise, it would be really awkward. And so that's how actors communicate. And so actors are just things that send and receive messages. Now, actors could also do things like spawn other actors and just create this network of actors. But those are the three basic parts of actors. And so if you have an
Just like
object,
I guess to recap, it's sending messages, listening to messages that you subscribe to, and then spawning other actors.
exactly. And that's all there is to it.
Actors are state machines as well, right?
Yeah, actors
They
exhibit.
encapsulate state machines, right?
Yeah, you can think of it that way. So actors exhibit state machine behavior, whether it's implicit or explicit, just because state machines and actors go really well together. Since actors define their behavior based on events they receive, and that's exactly how a state machine works.
Okay,
Would you have
so
a scenario
how
where there's no actor? It's just a state machine?
Well, so a state machine, it's like a blueprint. It's a description. It's like saying, there's a blueprint of a house, but there is no actual house.
Gotcha.
So, yeah.
So then, like, can an actor contain an actor contain an actor? Like, is
Oh,
there
yeah.
like infinite levels of nesting? And so, like, actors, even if they're nested and encapsulated, they still can listen to messages that are outside of their immediate scope,
So,
that are like like in the upper levels of the bubble versus the inner.
yeah, so first of all, yeah, actors could spawn actors all the way down. But as far as receiving and sending messages, that's another constraint of actors in that I can only send messages to someone that I have contact with. So right now, I could talk to all of you, but if I want to talk to someone in like the YouTube chat or some other live stream somewhere, I don't have a direct connection with them, so I cannot do that right now. And likewise, if you don't have a connection with me, then you can't send messages to me. Same thing with actors. So the way that actors talk to each other is by having reference to other actors, like having their email address or phone number.
That raises a question that I had, which is, are all of these messages point to point, or can you like subscribe to messages so you could get like a multicast type of
Yeah,
phenomenon
exactly.
going on?
Yeah, so actors are just the building block, and you could create abstractions on top of that. So one of the most popular libraries for just the actor model in general is akka, really popular in the Java and the Scala ecosystem. And they also have the notion of subscribing and topics and other things you might find like multicasting and all of that. And so, yeah, you could definitely build abstractions on top of just those basic actor model rules. Like, for example, if you want to build your own subscription mechanism on, actors, it's nothing new. It's just, okay, as part of my internal state, I might have a list of subscribers. And whenever a subscriber sends a message saying, I want to subscribe to you, I add it to that list of subscribers. So now I have a reference. And so when I feel like emitting or multicasting something, I will go to my list of subscribers and just, iterate through and message each one of them.
Okay, so I think I'm still a little confused. I'm sorry if I'm like super slow brain today.
It's all good.
But I'm still a little confused at like how an actor is supposed to know about another actor before they can communicate. Like, you can't just publish a name of an actor, like with like, or is that what you mean by that they need to know the name, like, or that they need to have contact?
Well, it's more like they have to have, reference. For example, how did you all know about me? How did I know about you? Someone probably told you, or you saw something on Twitter, which Twitter, you could think of Twitter as its own actor. So yeah. And so actors can come to know of other actors by two basic mechanisms. Either they're born with it. So when a parent's actor creates a child actor, could say, by the way, you know this actor, or, even as simple as, you know me as your parents. Or I could send them a message and say, hey, you should check out this other actor. This is a reference to that actor.
Okay.
Yeah. So you can send through messages.
That makes sense. That's awesome. I also love the like maybe they were born with it, you know. It's like a good
Yeah.
reference to like Lady Gaga's, you know, I was born this way. And then
Yep.
what's the other? Maybelline, maybe she was born with
Yep.
it, you know. Anyways, so so I think the question I have is like in terms of event flow, right? Like the thing that Flux architectures popularized in the front end was this kind of downwards data event propagation workflow, right?
Hmm.
And it kind of was an attempt to wrangle all of the spaghetti events that were flying everywhere in the front end community before that. Like think of Java, you know, jQuery code bases that didn't use like frameworks, right? jQuery is a library and code's just, you know, whatever. Things are using ifs and function scope in order to like encapsulate and so,
Hmm.
so there just was never a predictable way to like debug a problem because you never knew like what was talking to what. You know what I mean?
Right. Yeah.
And then we introduced this sane pub sub pattern in the front end and downwards data flow and like good component architecture and hierarchies. And so can you talk to like, are there some best practices or just like recommended flows for events or is that just like something that doesn't matter in the world of XState because, you know, once you are in a given scenario, there is going to be a level of determinism, regardless of whether that arrow came from above or below or from the side, you know?
Hmm. So I think one of the most important things is separation of concerns. And like with Flux libraries that love to just put everything in one global store, it's like you're either making an artificial separation of concerns or you're completely eliminating it entirely and saying everything is either global or figure it out, like I talked about. And so with XState, it really encourages you to be like, okay, if there is some like actor that's concerned with this and another actor concerned with that, then those should be two separate state machines or actors, however you want to make it. And it's also forcing you to abstract everything via events. And so that further reinforces separation of concerns because now it's no longer about like, oh, what's the right method name or what part of the data do I have to read from this data and when's the right time to read it? It's like, no, it's all just events. You're just sending in events and hoping that the actor does the right thing with it. And as far as getting state, it's receiving an event, whether you're subscribing to it implicitly or you're actually explicitly getting that event sent directly from the actor to the other actor. And so with XState, the architecture is really about simplifying and having everything in terms of isolated behaviors and message passing. And that's pretty much it. And so I feel like that makes your logic a lot more predictable, and it's something that you could even extract and communicate with non-technical people too.
For sure. Yeah, I think that's like the whole it helps you kind of decouple your design and discovery process. And I have to give credit to Alec Lavoie, who's a teammate of mine at Indigo, who was the first person who introduced me to XState. I had spent a few years kind of away from front end explicitly because I was at NPM and I was just doing things with Electron before that. And so I kind of came back into the front end world and then all of a sudden XState was a thing and Alec introduced me to it and he was really trying to push us creating state machines with our designers and incorporating that into our development process because it's like you get this artifact that you can then code against, right? Because here's your spec, here's this flow chart, you know, you can host it somewhere, you can put it in a GitHub issue, you know, and it's this thing that helps you decouple the design and discovery process and just make sure that you've got all your error states, you've kind of thought through all the different scenarios, and then, you know, you can decide what you want to support in this iteration, what you don't, right? Build in placeholders, and it's just a really great communication tool, you know, so really kudos for doing that. And kudos to Alec, you know.
And kind of touching on that,
Yeah. Sorry, go ahead.
like I think touching on that a little bit, Emil, you mentioned like an artifact being able to look at there. One of the first things that you'll see, and like if you go to the XState site, one of the 4 links on the page is to the visualizer, and that's this tool that lets you visualize the state machine in a non-code way. That's like a state chart. Is that what you would consider a state chart, David?
Yeah, that's a state chart.
Okay, cool. And I really like that because it's like that is something that you can take to your non-technical stakeholders and show like every possible state of an application or a component and then you have this hard coded diagram that then you can code against to actually produce the intended output, and it will only ever be the intended output because you can't be in any other non-defined state, which
Right.
is
Exactly.
really cool.
And it's interactive, so it's like hard coded, but it's like it's interactive. There's you know an interactive GUI to it,
And that
which
that
can
kind
all
of
be run in memory. Like you don't even need to be online, you know.
yeah.
So
How
That kind of brings
so
up a question. Oh, sorry. Go ahead, Caleb.
yeah, no, so the visualizer was also on my list of things to talk through because I love it. I think it is a key for thinking about these things, and as y'all are talking about, lets you bridge between things. The thing I'm curious about is, does it handle kind of multi-actor, multi-state messaging systems, or these sort of higher level architectures with orchestrators and things that you were talking about? Is that something the visualizer can show for us?
Yeah, definitely. Not the visualizer, the xstate.js.org/viz. That's actually an older version of the visualizer, and we're working right now on making a brand new version. But there's also the XState inspector, which works as a visualizer, but not for code that you paste in, but rather for code that's actually running in your application. And so what you do is you would hook it up to an application that's using XState, and that might be a actor with a machine, which might be spawning other actors. And so there's a sequence panel where you could actually see how those actors are sending messages and talking to each other. And this is actually another classic thing that you might have used before, I'm pretty sure, called sequence diagrams. Just like those, line diagrams where it's like, all right, this is going to here and that's going to there. And by the way, the little figures at the top, those are called actors in a sequence diagram too. Exact same thing. And so those are really useful for communicating like how different systems or different actors are talking to each other and what the potential scenarios are. So the inspector can do that. And right now we're working on just like a completely revamped visualizer/inspector that's just going to let you do everything, whether it's copy paste code in or, inspect applications in real time.
it's super cool. So XState is like framework agnostic, right? You can use this with any framework. It's similar to Redux. Does it have a bunch of dependencies, or is it like a zero dependency library?
Zero. Right now there's
Yes.
zero. And
That's
it's
awesome.
always going to be zero. Don't
And
quote me on that, but I'm
and-
really, that's a high level goal.
And like in terms of the source, because obviously there's a bunch of developer tooling that's not going to ship with your production source code, but like
Right.
out of what ships to production, like how big are we talking of a footprint? Like,
So yeah, that's a good question. XState is about the same size as MobX in that regard, around between I think 15 to 17 kilobytes minified. However, in version 5, we're working on making it smaller. And if you want to just use basic state machines and you're like, I really don't want to pull in all of XState for it, even though it's only 15 kilobytes, there's something called XState FSM, which weighs in at 1.5 kilobytes. It's really, really, really tiny.
it's like XState Lite.
Yeah, it's a flatter version of XState. So you're not going to get your, nested states or any of the fancy like history states or invocations or things like that. But for a basic state machine where you're like, okay, we could draw this clearly as a flat state machine, XState FSM is going to be your best bet.
Wait, so have you considered calling it Diet Estado? Like, because that would be a really good name. I don't know what
Letting
FSM
go of this,
is.
are you? Mel?
I'm just saying it's such a good name. I mean, I don't speak Spanish.
you could
but
call it
like,
Estadito.
Estado. Yeah, there we go.
Estadito.
Estadito. There we go.
I think I still have the NPM name, so you know what, I might do something with it, just as an Easter egg or something.
Something. Just publish copies of what's the latest main branch and onto there too, so people can choose to use that package.
It won't get confusing at all.
Not at all. It's like how React used to be called Fax.js, and
Oh, no way.
one-
I didn't
Yeah,
know that.
yeah. No one really uses that anymore.
It used to be called fax, like TH.
Like a fax machine. Yeah.
Oh, fax. Oh, that's so
Yeah.
weird. Yeah. So in terms of like what XState offers, like, there's the visualizer, there's obviously the core source library, like what else is there?
Oh, there's a lot. So there's the visualizer, the inspector, the core library. There is something called XState test, which, like I was talking about earlier, it's a model-based testing library where you give it a state machine describing your application, and it will automatically generate like all the hundreds of different ways that someone can interact with the application, and then you just run that through Jest, or add Puppeteer or Playwright to that too, and it's going to basically write the tests for you. There's also what else do we have? XState Immer, if you want to use Immer with XState. XState FSM, XState Graph, which is just graph-based utilities for XState. That's really useful for like all of our visualization and graph drawing parts of XState, and actually mapping out all of the states. And we're thinking of some future packages too. Besides like the adapters to React and Vue and Svelte and all of that, we're thinking about like a XState router and an XState form. So we're still planning those. It's going to become a big ecosystem.
Would
Just
would
state
that, like,
machining goodness.
as an example, would XState router be like a replacement for like a React router type component, or would it work in tandem with that?
It would probably work in tandem. Whereas with a React router, it's like, all right, just define your routes as components, and if you don't want a route showing, then just don't render it on the screen. XState router is more like, give us all of your routes up front. We're going to map it out for you so that you could either navigate directly, or if you click next, then the state machine knows exactly where that next link is going to be, instead of hard coding it into your application view layer.
Oh my God, that's like mind-blowingly, just like, even just like hearing that makes me feel good. But yeah, no, I think there's a lot of stuff around URL management, source of truth for state, kind of server meets client kind of transitions for SSR apps, like all that kind of stuff I want to get into, in like middleware patterns that were popularized with Redux, like what's the kind of XState equivalent. But yeah, I guess we'll maybe we'll get into all that good stuff right after these messages.
Mm-hmm.
Nice. Cool. I was like right at 20 minutes.
All right.
Nice.
Okay. Anyone need a break?
I have my water.
I'm good.
Cool.
Still sweating.
So
Do they not have
for-
AC up there?
No, we live in the mountains, and we don't really need air conditioning. It's just like climate change is giving us more hot days than normal. And then our like windows are like awkward shapes. It's not like I can just like stick a window unit in there really easily. But if it keeps up, I'm probably gonna get like a portable air conditioner, like, and just cave in. But we're definitely not getting HVAC or anything observantly like extravagant like that, So keep this house rustic. All right. So yeah, so I'm happy to kick us off, but I also feel like I've been talking a lot, so I don't know.
That's fine with me. I'm trying to map. We've been kind of jumping in and out of different sections, so
No pun intended.
it's totally fine. If you want to, unless Cable, you have any you want to kick off at all?
Well, I mean, I'd love to dive deeper into this idea of state-driven routing, state-driven applications, and how that relates to the age-old declarative versus imperative approaches to things. But Amel, if you had something more pressing you wanted to kick off with.
Yeah. I mean, basically, what I want to talk about can be segued from there. So if you want to go for that, let's do that. Because I want to get into like, my personal philosophy, which is like your application URL should be your state of truth, for and you should be able to rehydrate your application just through that URL. And kind of want to talk about like persisted states in the client, and then I want to talk about like middleware patterns, and then also cover like the server side workflow, like because servers are they're bug farms and they're huge state machines. So like how can we use XState in the server, but also
I think calling a server a state machine, maybe that's the infinite state machine.
and they're bug farms because they're really badly written, right?
Yeah.
So and encapsulation is
software.
another huge problem. Yeah, it's software, right? No judgments.
Yeah.
Everybody has embarrassing code. So So yeah, I mean, but I would say like what you want to talk about is a good segue into that stuff.
Okay.
And I think the only thing I want to maybe shout out is like one of my friends who I really respect, like as an engineer, but you know, he's very back end heavy and he's really into kind of pre-rendered views and static kind of clients. And so, you know, he doesn't believe in like he doesn't understand why JavaScript like apps need state machines or state management at all. He thinks it's overkill. So I'd love to hear like what David has to say about that.
Ooh, that's a fun topic.
Yeah. So yeah. So anyways, floor is yours, Kibo.
All right, so let's bring it back and talk a little bit more about what we were just leaving off on around state machine driven routing. And the piece of this that I want to kind of dive into is one of the age-old pendulums in software development generally, and that we've seen between imperative and declarative approaches to programming. And I think we see this in our front-end frameworks. React is very imperative, even though it enables a more declarative view of components. Vue is actually a much more declarative model for programming and mental model. But I think when it comes to stuff like routing and application state, one of the nice things that you can get with a state machine approach is it feels, once again, very declarative, something where you can say, these are the ways that the world should be, go and make it happen. And I'm curious, is that something that you're seeing people use XState to do? How do you think about that? How much of that kind of mapping from here's the declaration to what does the app need to do does XState do for you versus you have to implement?
So yeah, people have been experimenting with using XState and routing, and there's a handful of libraries just sort of playing around with this idea. And it is something that we need to think about more, just because there's something that seems to go against what a state machine is, which is the fact that I can navigate to any routes I want just by changing it in the address bar. So it's not exactly an event. It's more like, hey, just teleport me directly to this state. And so now it's not really super against what a state machine is. It's more like there's these implicit transitions where you could just transition to any state at any time. But those still need to be made explicit. You should know like what are all the routes you could go to. And also, as state machines are, very founded on like just having your application logic be safe, there has to be some safeguards for like if I go to /admin, it's going to check, am I logged in? Otherwise, it needs to boot me to a login screen. Well, all right, ideally I should be logged in and an admin. I can't just be logged in and do all sorts of crazy stuff. But yeah. Some of the earliest examples I've actually seen of using state charts was actually before I even started programming. It was with Ember, or when Ember used to be called Sprouts Core. Sprout Core used state charts a lot, and so this was like, again, before I even touched, well, I touched computers before then, but before I like was really hardcore into programming. And it was really interesting. There's actually this experiments with Ember and routing and using state charts for routing. And it actually has some pretty cool state chart diagrams, and that dates back to 2013, I believe. So this problem has been thought about a lot before.
Well, Ember was a big advocate of what you were talking about, Amel, on the break, of everything stateful about your UI being driven by your URL, and your URL representing your state.
Yeah, I'm convinced that like Ember developer, like the core team, they're like the game developers of the JavaScript community. Because like how there's that saying that like, hey, everything you've thought of like as your big new idea, like game developers invented 10 years ago. Like I feel like Ember, like they just so many things that like they did right.
Dojo already
And
did that.
Dojo too, right? But the point is, it's just amazing to see how certain patterns were in the zeitgeist very early on, but they just didn't get the traction until people like burn their hand in the pot and then like learn the hard way, And that's the thing. Sometimes people just don't, like, you can preach all you want, but until they get burned and or see the merits for themselves, with increased velocity, reduction of bugs, better predictability, like faster onboarding, right? So this isn't just actually about how your users experience your application, because quite frankly it's like an invisible thing for your users, right? But it's really kind of a tool for how we do our internal data and code management. So
Yeah.
communication is a big part of that, I think, both for onboarding as well as just external stakeholders that are non-technical.
It's funny, I wanted to mention, even with game developers, you talk to them about state machines, you're like, yeah, I've been using them. We've been using them for decades. Like, why do you think it's a new thing? It's not.
Right. Yeah.
Yeah.
They're like, oh, we have something. It's called Estado. Just kidding. Just kidding. Just kidding. Just kidding. I'm going to stop trying to make Estado happen. I'm like, this is like my fetch, I keep trying to make fetch happen.
Bone Skull, one of our regular panelists, was commenting in the chat about this. He's like, why are there so many state libraries and ceremony around state libraries in the front end of JavaScript world? Like, this is a solved problem. The solution is state machines. This has existed for a long, long time. I'm actually kind of curious, David, as you've been kind of marketing XState, bringing this to the world, do you have any insight into why the front end world in particular has been so slow to adopt state machines and be interested in this?
Yeah, and trust me, it's been an uphill battle because, first of all, we don't like being told that the way that we're doing things is like not the best way to do them.
You could have just stopped right there, where you're like, we don't like being told anything.
Right? Yeah. And so people are like, oh,
it's amazing we even have people listening to this podcast. Quite frankly, So.
Yeah. No, there's people who are like, no, you're being a thought leader. You're trying to introduce something new, etc. And what I'm doing works and is just fine. And so I'm over here trying to say, like, first of all, what we're doing is just a pale imitation of what we should be doing, which is, modeling these things as state machines, or at least some sort of events-driven architecture, rather than trying to manipulate state directly. And notice, I didn't say mutate state directly, because all of these state management libraries are like, okay, we're technically not allowed to imperatively mutate states, so we're just going to give developers a really easy way to manipulate states. But it's still sort of the same problem. Like, all right, now you avoid the problem of having shared data access, but you're introducing a new problem of, like, you don't know when things are going to change just because they could change from anywhere. And that's a huge problem. But yeah, XState takes the approach of, something that's been around for, just many, many decades. And also, we were talking in the break about, like, how someone was like, why do we even need state machines anyway? The way I'm doing things works just fine. So I'm sort of rallying against that works just fine, because that's only half the battle. Like, we don't code just to make something work. We code to make it work, to prevent it from not working, and to also communicate to the rest of our team, and ideally even to users and designers and other people, how the app is supposed to work. So I could code something in assembly. Actually, I can't. I don't know assembly. But I could code something in C where it's like, okay, like I made this complex thing. It works. Don't touch it. But no one else will understand it. And I feel like my job is incomplete if the code I write is not understandable by others.
Amen. Can we just take a moment of silence? Just preach on, brother. Seriously, that I couldn't agree more. Honestly, like, the other really big thing is that, when you read code sometimes and you're like, oh my God, like, what's up with the paranoia level in this code? Like, it's like like all these shields from all these angles. It's like, Jesus Christ, is this like some function that's used in every file and every method? Like, why are you being so, like, shielded? Like, you can kind of reduce that paranoia level as well in your code. And for me, more importantly, this enables you to optimize your code to be easily changed and extensible, right? And, like, we don't talk about that enough. I've been on this kick lately where I'm like, optimize for change, everybody. I've like said that like literally 100 times this week, because if we're, we have to optimize our code for change. Like, if we think that our code is not going to change, or that this thing should stay the way it is, like, you are not living in a reality that is like, like real world, application development, right? Code is living, breathing, craft, you name it. Like, people, come and go, and, libraries die, things need to kind of move on, and, you just, you have to like be able to kind of weather that change and support easy pivots, right? Especially if you're a startup or a small company that's still like trying to validate your product market fit,
Right.
and so yeah, like I mean, it's just huge for kind of, I think, bringing that ease of communication and determinism, into your applications. Like,
Yeah. And that's the point. So I want our app logic that we write. I want that to be a communication mechanism, like something where we could create that visual artifact and share with other people, like, hey, this is how it works. And then if they're like, well, like you were talking about, this is going to change, or I need to add this feature, we could know exactly where the app is going to be affected. Whereas if you just do things the normal way we've been coding for many years, it's like, okay, this is another Boolean that's going to go in a dozen of our if statements somewhere, and we're going to have to check it all. And let's hope we have tests, but there's a really good chance that we don't have tests to capture this behavior.
Now, I find that I think there is a level of to which, like, this is another thing to have in your mind, another learning curve to climb. And part of the challenge here is we're still navigating this transition mentally from front ends being simple to front ends being where much of the complexity of our applications lands. And that transition is playing out in many, many different domains. But I think even within an application, right, like to your point, managing one Boolean is not very hard, is not very much mental overhead, and is, if that's all it's ever going to be, probably simpler than incorporating a state machine library.
Yeah. Mm-hmm.
So a question I have for you is, do you have a rule of thumb or of kind of what level of complexity, what number of different factors or states does it start to become worthwhile from a mental overhead standpoint to incorporate a state machine?
So there's no hard and fast rule. If there was, I would say, like, as soon as you're getting to 3 Booleans or more, then, maybe consider how the different behaviors of your app, can change and, just what they are. But yeah, so, I always say, like, you don't need a state machine if your app isn't complex. I also say that your app will never stay complex unless you're doing some sort of toy project that you forgot about, or, like just a simple app, like, I don't know, even I was thinking of like the Yo app where you just like press Yo to your friends. Like, even that has enough complexity that merits a state machine. But yeah, we're not writing simple apps. We're not paid to write simple apps. We're paid to write apps that are eventually going to grow in complexity and features and edge cases, and we need some sort of scalable way of managing that.
Mm-hmm.
Yep.
And yes. I'm sorry. Go ahead, Nick.
I'm going to tangent a little bit, so go ahead.
Okay, well, so I wanted to say, so we kind of said this a little bit quickly, but like, so I'm a fan of, your source of truth in your application being in your URL. Your applications should always be able to rehydrate from a URL refresh, somebody refreshes their screen or they're in a Wi-Fi situation, like they should be able to refresh and like stuff shouldn't break, and so I'd like to kind of understand, how XState makes that reality easy, and the whole kind of like rehydration states, and also in particular when working with clients and local storage, if there are tools or utils or kind of patterns around like rehydration of your application state.
And this
Yes.
might tie in a little bit
sorry.
to what I was going to ask too, so I'll just kind of throw it out there as well.
Sure, great.
But I was going to kind of ask about maybe I'm not fully seeing like how it's implemented, or how it's like implemented in practice. And like if I were going to try and implement a state machine in my existing app that has a lot of already kind of managed state with a bunch of different things, like maybe a lot of stuff in contexts and providers and all of that, is XState like a way to manage that component state that it might exist out there, or like some other global state, or is it more it should take the reins from that?
Yeah, that's two really good questions. So I'll talk about the persistence one first. XState does have a way to basically take whatever state your state machine is in, including any extra data, which it doesn't really fall into the finite state category. You could persist that, and then you could restore the same machine at that given state. So in a way, it sort of acts
Nice.
like, any other state management library where you could do that. And right now we're working on, and this is a hard problem to solve, but we're working on a way of also persisting actors. So if your state machine is in a state where there's other child actors who also might have other child actors, then pretty soon you'll be able to persist those as well and restore those actors to those states, or at least try. Like, for example, if you have a promise request or something, then chances are you're going to need to rerun that promise request when you reload the page. And
Yeah, but you know what? This kind of brings me to my next thing, which is kind of actually middleware patterns, because I could very easily see there being a middleware that was activated anytime there's a promise, and it knows how to handle a cancellation state or like a failed state, or so you're not like repeating a bunch of code everywhere in all these different actors. And so, because Redux kind of popularized the middleware model, right? So did Express, if we're like really go back a little bit further. But, it just kind of was like, here's a bunch of things that'll run every time there's a state update. And if it gets triggered, if it may or may not trigger some business logic that's in your middleware. For example, like if there's an error, like log to Sentry, right? That's one thing you put in your middleware if you want to normalize some data, if you want to do some analytics, or
right.
whatever.
Yeah.
So what's the XState path for that?
And this sort of bleeds into Nick's question too, but you might be either happy or sad to know that there is no such thing as middleware in XState, and there never will be. And that's because XState has this abstraction of state and events, and that's pretty much it. And well, also actors, which encapsulate those states and events. And so everything works through that. So if you want to add analytics to something, then your state machine, it has a subscribe method, just like anything in RxJS. And you could do whatever you want with those state updates. So you could send it to some analytics or some logging service and do things that way. Now, Redux and libraries like it, they need middleware to handle side effects, and that's because they are completely hands-off with side effects. XState, on the other hand, says no. Side effects, which XState calls actions, are extremely important. Like your app will not work without side effects. So we need some declarative way of managing side effects. And so that's exactly what XState provides. And so it does so in terms of spawning or invoking actors, or even just performing one-off actions. So yeah, it has that built-in notion. So instead of requiring middleware for that, that's just part of like just the notion of actions and services, which you can provide externally too. And so,
well, I guess my thing is, how do you avoid duplicating subscribes or events everywhere, right? Like if I want something to happen every time a data fetch is triggered, how do I avoid needing to update like all of these different state machines in my app? You know what I mean? Like, is there a way to centralize that? Is there like a hook for before all or after all, or,
there's,
I mean,
there's different patterns. And this gets sort of more into advanced XState, but you could have like parallel states, and you could also have actions that happen on every event and things like that. But the easiest way to get started with that is just, calling .subscribe and handling state changes that way.
okay.
So,
Wow.
yeah.
Very cool.
Does XState work with suspense in React?
Oh my God, can we not talk about suspense?
Does
That is a
anything work with
broken API.
suspense?
That's a better question, I suppose.
No. So suspenseful and concurrent mode, that was a something tricky that we were trying to
Bad
figure
idea.
out for
That was a bad idea.
I won't say it out loud, but
It's okay.
and
I can say it. I don't have any.
that's why I'm really glad that concurrent mode sort of just didn't become a
I have
whole
no
mode,
shame.
and it became like more isolated things. But XState does not work with suspense yet. By working with suspense, we mean like just having these built-in things where it could actually throw promises and say, hey, I'm in some sort of pending state. I think that that's a good idea, at least to support. So we're going to just experiment with that. Definitely not priority. But And so going back to your earlier question, Nick, about like how it integrates with like existing code and other libraries, you could use XState like either at the smallest level or at some, global orchestration level. It doesn't need to encapsulate or like just take over your entire application states. You could definitely do it incrementally. And that's a good way of using XState as well.
Yeah, that's actually a good point because that actually helps with incremental kind of adoption and refactoring in place.
Yeah.
Some of your slowly refactoring your views and components to slowly be managed by XState. That's pretty cool. So as we're kind of winding down here, how can folks contribute to the project? It sounds like definitely have a roadmap. You've got an active, kind of healthy project. And so how can folks contribute and get in touch with you?
Sure, we're always accepting pull requests, especially for documentation, and we actually have a new. I should have done this years ago, but we have an examples directory on the page where we're just filling it up with as many useful examples as we can.
Like recipes?
Yeah. So the recipes are also in the documentation as well, like how to use this with Vue or Angular, etc. Yeah, so that and also participating in the discussion forums. So if you go to discord.gg/xstate, there's just a whole lot of really helpful people in there, either sharing crazy ideas or offering help at all hours of the day. And I know because I'm one of those people offering help at all hours of the day over there. So yeah, just participating and trying it out on your projects.
That's so awesome. And where is XState being used right now? Because I remember, this goes back to my conversation with Alec. I have a very healthy skepticism for new technologies and especially when to adopt them at a large corporation, because I have to, if I'm going to push a tool, then I have to take on the maintenance burden of making sure everybody's aligned and trained and everything is updated and standardized. So it's not an easy thing or something I take lightly. And I remember because I hadn't heard about XState when Alec Lavoie introduced it to me, I was really like, I don't know, where is this being used? Like, especially like, I don't know if this is like JavaScript's new hot thing, you know what I mean? So can you give us kind of a sense of like what that adoption curve has been like for you?
Yeah, sure. So I actually asked this question on Twitter a few months ago, and I was surprised to learn that there's a lot of companies using XState in production. Notably, Microsoft, even I didn't work in any projects at Microsoft that use XState. It's just like Microsoft's a huge company, so they've used XState in various projects, including one of their education tools and also the Microsoft To Do app.
Wow.
Netflix is using it, Lego. Amazon is using it in their AWS Amplify service to handle authentication. So you could say that XState is being indirectly used by just hundreds of thousands of developers, that way.
Wow.
It's part of Gatsby as well. Honestly, there's a lot of places that's
I can't think of
used.
a project that isn't in Gatsby. Gatsby's like the kitchen sink.
It's
like
either
frameworks.
Gatsby or Next.js.
Crazy,
So yeah.
So cool. Well, thank you so much for your time, David. It's been an absolute pleasure. And yeah, I'm excited to try this in production. It's definitely it's on my recommendation list for the UI architecture at Indigo.
All right.
Likewise,
Awesome. And pretty soon I'm gonna write a getting started with XState in 3 minutes article. So zero
Nice.
Excuses.
Cool. Let us know. We'll retweet it.
All right.
Well, thank you so much for coming on. Thanks, K-Ball and Amel, for joining, and we will see you next week.
Bye, kids. David, this was so fun. Thank you.
It was. Yeah. Thank you so much for having me on. It was a blast.
Thank you for putting up with my sometimes obscure hypothetical questions.
No, they're really good questions. Yeah, I appreciate
K-Ball, you're
it.
so smart. I want to be you when I grow up. You know that, right? It's literally been on my list to ping you and tell you this.